Welcome to our help video over page 5 of the test. We do want to finish problem number 28 though, question 28 from the 4th page. So far we were up to letter D, antimony, and we fell short of time on our video. So antimony 3 plus is circled as the one that has not satisfied the octet rule. Let's be sure we understand why. We come over here to our periodic table of ions. Here's antimony right here. It can become 3 plus or 5 plus. Now, this is in family 5. Above the line, family 5 wants to gain 3. Above that stair-step line, it wants to gain 3. Here's the stair-step line. Below the stair-step line are the metals, and they're the ones that are all positive. So when you see positives, they're going left. Positives are going left. So how many spaces left do we need to go from family 5 to get back to 8 in order to be stable outer octet like 8? Well, if we count them, we would have to go, we're in here, and we'd have to go 1, 2, 3, 4, 5 to get all the way back. So antimony would love to be 5 plus. If it becomes 3 plus, it can become 3 plus. It will not have satisfied the octet rule, though, in the clearest sense of the octet rule. So antimony would be circled in this line. It would have to lose 5 to go from family 5 all the way back to 8. Helium is a noble gas, so that one's stable. We see helium right here. That's a noble gas. It's satisfied the duet rule. Helium has 2 electrons. That second level holds 2 electrons. Or the first level holds 2 electrons. There's our first level. There's 2 electrons. That's all it holds. It's stable, the duet rule. All right, now we're on to our next page, page 5. A cation with a charge of 2 plus. So it's a plus. And it now has 18 electrons. So it has 18 negatives with a mass number of 44. So it has 18 negatives. If it's 2 plus, that means there's 2 more positives than negatives. So that means it must have started with 20 electrons and it has 20 protons. So if it's 18 electrons and it's 2 plus, that means there's 2 more positives than negatives. It has 20 protons. Protons are positive. Cation has 20 protons. True. The cation has 26 neutrons. Well, they told us the mass number was 44. We established in letter A that there's 20 protons. The mass number minus by the atomic number. Mass number is protons plus neutrons. Atomic number is protons. So if we take protons plus neutrons minus protons, we're left with neutrons. So the mass number is 44. The number of protons is 20. 44 minus 20 is 24, not 26. Letter B is a false statement. The cation satisfied the octet rule. Letter C. Well, it has 18 electrons remaining. If it has 18 electrons remaining, it has the same number of electrons as argon, who's stable. Argon's in family Roman 8. It satisfied the octet rule. Argon's in 8. Octet rule has been satisfied. The cation would be in Roman 2. If it's 2 plus, what Roman is it in? We look on this table right here. Here's the 2 plus. It's in Roman 2. Here's calcium right there, number 20, 2 plus, Roman 2. That's a true statement. The nuclear symbol would be 44 and 20. There's the 44. Mass number goes in the upper left-hand corner as a superscript. Atomic number we established was 20. 20 protons, that's lower left. That's the nuclear symbol. Remember, when it's an ion, you put the charge of the ion next to the symbol if you're doing proper nuclear symbol format. The cation on the problem above, we already know has 18 valence has 18 electrons remaining. Excuse me. It has 18 electrons remaining. It would have the same total number of electrons as all of the following except one of these. So how many does scandium have? Scandium's 3 plus. We come over here. Scandium's 3 plus. There's scandium. It's 3 plus. 21, if it's plus, it's lost electrons. It has 21 positives. It would only have 18 negatives for it to be plus. 3 more positives than negatives. 21 minus 3 is 18. Same number. as calcium. Phosphorus, phosphide ion, 3 minus. How many does 3 minus means? There's 3 more negatives than positives. We come over here. Here's the phosphide ion. It has 15 positives. If it has 3 more negatives than positives, it now has 18 electrons, just like argon and calcium, who we're comparing it to. We already established had 18 in the previous question. Potassium, 1 plus, the potassium ion. If it's plus, that means there's 1 more proton than electron. We come over here. Here's potassium. It has 19 protons. If it has 1 more proton than electrons, then it only has 18, just like argon. 18. So they all have 18. And in this calcium 2 plus also had 18. What about letter D? S. And this is 1 minus. So that if it's S, 1 minus, it means there's 1 more negative than positive. Sulfur has 16 positives. If it's minus, there's 1 more negative than positives. It only has 17. It would need another one. It does not have 18 total. It would only have 17 total. Argon already has 18. Look at this. Argon, if you look on the periodic table, there's its 18. Again, just like calcium 2 plus would have 18. As we mentioned, for calcium to be 2 plus, that means there's 2 more protons than electrons. It has 20 protons. If there's 2 more protons than electrons, there would only be 18 electrons. So we already established that calcium had 18. The cation, oh wait, we just did 30. Holy cow, we could do it again. No thanks. What about number 31? An anion with a charge of 3 minus has atomic number of 7 and 15 nucleons. So if its atomic number is 7, that means there's 7 protons. If it's 3 minus, it means there's 3 more negatives than positives. So how many would it have? That would be 10. If there's 3 more negatives than positives, that would be 10 if it has 7 positives. Which of the following statements is false? The anion has 10 total electrons. Yep, we just figured that out. The anion has 10 neutrons. Wait a minute. 15 nucleons. It has 15 nucleons. Nucleons are protons and neutrons in the nucleus. So it has a mass number of 15. Mass number gives us the nucleons. If it has 7 protons and 15 total particles, it would only have 8 neutrons. 15 total particles minus 7 protons means 8 of them are neutrons, not 10. That's false. The isotope could be nitrogen, 14. Well, first of all, is this even nitrogen? Atomic number 7. Who's atomic number 7? Nitrogen is atomic number 7. The hyphen notation for this one then would be nitrogen hyphen 15. Could an isotope be nitrogen hyphen 14? Absolutely. For it to be isotope, they both have to be nitrogen, but their mass numbers would have to be different. That's true. This mass number is 14. The original atom had a mass number of 15. Based on the charge of the ion, it would be found in Roman 5. Let's find out. Nitrogen. We know it's nitrogen and it's 3 minus. If we look on the periodic table, if we look at our periodic table of ions for sure, there's nitrogen. We've already found it was nitrogen. Nitrogen has a Roman 5. They want to be 3 minus. The atoms that want to be 3 minus mean they have 5. That 5 is 5 valence electrons. 3 minus would give it 8 total. Remember, when you're minus, we're moving this way to the right. The nuclear symbol for the anion being shown above would be this one right here. Well, it's 3 minus charge. The charge goes there. Atomic number of 7. We knew it was nitrogen. Atomic number goes in the lower left. The mass number goes in the upper right. Mass number gives you nucleons. That is the correct symbol. Number 32. Use this symbol to answer the following. We have tellurium. It's 2 minus. It has 52 for its atomic number, or 52 protons. It has 128 for its mass number, which is total protons and neutrons in the nucleus. Does it have 128 nucleons? Absolutely. Letter A is true. It says 128 right there. That's the mass number. Nucleons are particles in the nucleus. The anion has 50 electrons. Hold on, it has 52 protons. If it has 52 protons and it's 2 minus, it means there's 2 more negatives than positives. So it would have 54 protons, or 54 electrons, not 50. The anion has 76 neutrons. Well, here's our mass number. Here's our atomic number. 128 minus 52 would give us our number of neutrons, which is 76. That's true. A nuclide to the atom above could have a mass number of 128. Remember, nuclides are identical twins. So if this one has 128 particles in the nucleus, so must the nuclide must have 128. Same atomic number and same mass number on nuclides. An isotope could have an atomic number of 52. If it's an isotope, it has to have the same atomic number. So it must have a 52. And its mass number could be 130. Absolutely. So how are isotopes different than nuclides? Both isotopes and nuclides have to have the same atomic number. Isotopes have to have a different mass number. Nuclides would have to have the same mass number. And that finishes page 5 of the test.